Okay, let's continue on with number 23. And let's see, what it has asked us to do. It asked us to write the slope-intercept form of an equation that passes through. So we know it goes through the point negative 4, 2, and is parallel to 2y plus 3x is equal to negative 4. Okay, so this is going to require a couple of steps. Parallel means it's going to have the same slope. Okay, so the first thing I'm going to have to do is find the slope of this line. So I'm going to put it in slope-intercept form. So I'll subtract 3x, 2y equals negative 3x minus 4, and then I'll divide everything by 2, each piece. So I get y is negative 3/2 x minus 2. I don't really care about this. This is what I'm looking for. Okay, this is my slope. So now I have a slope and a point, so I'm going to use the point-slope form, which is y minus y1 equals m times x minus x1. I know this is x1, I know this is y1, and this is m. So y minus 2 is equal to my m times x minus negative 4. So that's y minus 2 equals negative 3/2 times x plus 4. So y minus 2 is equal to negative 3/2 x, and negative 3/2 times 4 over 1 is negative 12 over 2, which gives me a negative 6. Okay. Then I'm going to add 2 to both sides, and I get y is equal to negative 3/2 x minus 4. And that is my equation of the line parallel to this through this point. Okie dokie, 24. Oh, excuse me. All right. Write the slope-intercept form of the equation that passes through the points negative 3, negative 2, and 1, 8. Oops, you want to see that, I guess. Okay. All right, so I've got 2 points, so the first thing I'm going to do is find the slope. So my slope is equal to y2 minus y1 over x2 minus x1. We'll just call this x1 y1 and x2 y2. So my slope is y2 minus y1 divided by x2 minus x1. That gives me 10 over 4, which is 5 over 2. All right, so I'm going to use this as my slope and one of the points and use the point-slope form, which is y minus y1 is equal to m times x minus x1. I'm done with it. I'm going to use this one because they're all positive. So I know y minus 8 is equal to 5/2 times x minus 1. So that gives me y minus 8 is equal to 5/2 x minus 5/2. So I'm going to add 8 to both sides. So that gives me y is equal to 5/2 x. And if I have negative 5/2 plus 8 over 1, that's the same thing as negative 5/2 plus 16/2, which gives me a positive 11/2. And there we have it. We want to describe the end behavior of each function in proper notation. Now remember, for this, your end behavior is based on the degree and the coefficient. Okay. So if the degree is even and it's a positive coefficient, then the ends go the same direction. If the degree is odd and it's positive, they go in opposite directions. If it is an even degree and a negative coefficient, it turns it upside down. If it is odd and negative, again, it turns it upside down, so it goes up on the left and down on the right. Okay. And then, of course, we have to put it in proper notation, which is as x approaches negative infinity, f of x approaches something, and as x approaches infinity, f of x approaches something. So if we can find the degree and the coefficient, then we can do this right up. Okay, so for 25, it tells me that f of x is negative 3x to the fourth minus 2x plus 5. Okay, so I look at my leading coefficient. The degree is an even number, and the coefficient is negative. It's actually a negative 3. Since it's even, they go in the same direction. Since it's negative, they both go down. So, as x approaches negative infinity, f of x approaches negative infinity. As x approaches infinity, f of x approaches negative infinity. And this is the appropriate notation. For 26, we have g of x is equal to 2x to the third minus 5. Okay, so I'm looking only at the lead term. The degree is odd, and the coefficient is positive. I don't care if it's a 2 or I don't care what kind of number it is. So that is odd positive. So that means it's going to go down on the left and up on the right. So as x approaches negative infinity, f of x also approaches negative infinity. Oops, and this is g. I bet I did that on the key too. I'll have to fix that. Yep. As x approaches positive infinity, f of x approaches infinity. Oh, and that's not 26, it's 25b. This is A. Okay, 26. Oops, that's on the next page. What did I do with it? Here it is. Okay. So, we want to sketch a couple of graphs. Now, I'm not going to get out the graph paper because it's just really not necessary. We just want to sketch a graph. So for 26a, we have f of x is equal to x times x minus 3 squared times x plus 5 to the third. Okay, so here's what we need to know for this. We need to, again, know our leading term for our end behavior. So we need to know the leading term, and we need to know the zeros and their multiplicity and what it does at the graph. Okay, so if I want to find my leading term in factored form, this really could be written as x times x minus 3 times x minus 3, x plus 5, x plus 5, x plus 5. To find my leading term, I'm just going to multiply everything, the leading term of each. So x times x times x times x times x times x. And that 1, 2, 3, 4, 5, 6. So the leading term is x to the 6th. That is even, positive, so my ends will go like this. Okay, so let's find my zeros. Well, here x equals 0, and the multiplicity is 1. So that means it's going to cross. Here, if x minus 3 is 0, that tells me that x is 3. It has a multiplicity of 2, so it's going to bounce. And if x plus 5 is equal to 0, x is negative 5. It has a multiplicity of 3, so it's going to cross, but it's going to be flattened. We didn't talk a whole lot about that, so don't worry if you don't flatten it out, if you are asked a question like this. Okay, so on my grid, I know I have a 0, I have a 3, and I have a negative 5. Now the end behavior tells me that beyond the 3, it will never cross the axis again, so it's just going to go up forever and ever. Same thing at the negative 5. These are the only places it touches the x-axis, so once it goes above it, then it's on its way. Okay, so let's see here. At negative 5, it's going to cross, but it's going to flatten out a little bit. So it's going to look something like that. At 0, it's going to cross, and then at 3, it's going to bounce. So it's going to touch this and then turn around and go that way. And that's all you need in order to graph that. Okay, let's look at B. Okay, the function has zeros of negative 2 with a multiplicity of 1, 5 with a multiplicity of 1, and 0 with a multiplicity of 2. So it's going to cross, it's going to cross, and it's going to bounce. Okay. It doesn't tell me anything else. It doesn't tell me the leading term. Okay, so I don't know if it's positive or negative, but I do know it has an even degree because there are 1, 2, 3, 4 solutions. And let's just, for ease, let's say it's positive. Okay. So I know I have a negative 2, a 0, and a 5. Okay, so if you had said negative, that wouldn't be wrong as long as the zeros are correct. Okay, so it goes up here and up here because I decided it was positive. At negative 2, it crosses. At 0, it's going to bounce. And then at 5, it crosses. And there you have your graph. Okay, 28 I'm going to do on the review. Okay. All right, so we've got the parent functions for 28 and 29 graphed. So what I want to do is be able to figure out what the transformations are and then sketch the graph. Now on the test you can either do it on this grid, but we'll give you a clean one to do as well. I prefer to do it on here. Okay, this here tells me it is a vertical reflection. And this is going to be across the x-axis. And this tells me it is shifted down 2. Okay. This I want to do first because it's closer to the x, just your order of operations thing. So I'm just going to take each point and do that. So the positive 3 y coordinate becomes negative 3, and then I move it up 2. So it goes to right here. Oh, down 2, excuse me. Sorry. All right, this positive 1 y coordinate is reflected to become negative 1 and down 2. Positive 1 becomes negative 1 and then down 2. Positive 4 becomes negative 4 and then down 2. Negative 4 becomes positive 4 and then down 2. So now I just connect my dots. And we didn't do any stretching or shrinking, so it should look the same, just upside down and scooted down a little bit. And in fact it does. Okay, I've got g of x graph below. I want to graph g of x minus 3 plus 1 and describe the transformation. Okay, this is a horizontal shift right 3 units. And this is a shift up 1 unit. So I'm just going to find some points on here and move them all to the right 3 and up 1. Okay, so I'll take this one and move it to the right 1, 2, 3 and up 1. 1, 2, 3, up 1. 1, 2, 3, up 1. 1, 2, 3, up 1. And 1, 2, 3, up 1. Once again, there's no dilation on this, so it should look just very similar to the one we graphed, just shifted to the right and up. Okay. All right, let's do some 3 variable systems. So what I'm going to do for you is I'm going to do A using matrices and B using elimination. Okay, so I will start out by writing my matrix. Okay. So you have your equations here. So my augmented matrix is going to be 2, 4, 4, 4, 1, 3, 1, 4, and negative 1, 3, 2, negative 1. Okay. All right, so I want to start, I want this to be a 1. That's the first thing I do. There are all kinds of different ways to do this, but what I see is these are all even numbers. So if I just take each of these, if I take row 1 times 1/2, this will turn into a 1. So that becomes 1, 2, 2, 2, 1, 3, 1, 4, and negative 1, 3, 2, negative 1. Okay, this row is perfect. So don't use again. Okay. It's always, that's what it's going to be in every matrix. So now I'm just going to look at these two. The next thing I want to do is turn this into a 0. Okay, so if I do that, let me do my matrix. I have 1, 2, 2, 2. If I add these two together, no, I take that back. I'm going to subtract this one. So I am going to now take R1 minus R2 and put that into R2. Okay, so 1 minus 1 is 0. 2 minus 3 is negative 1. 2 minus 1 is 1. And 2 minus 4 is negative 2. And then if I add row 1 plus R3 and put it into R3, that will make this a 0. So 1 plus negative 1 is 0. Two plus 3 is 5. 2 plus 2 is 4. And 2 minus 1 is 1. Okay. Okay. So now my next thing that I want to do is turn this into a 1. So I can do that simply by taking R2 times negative 1 into R2. So again, I'm leaving my top row alone. If I multiply by negative 1, this becomes a positive 1, a negative 1, and a positive 2. And then I've got 0, 5, 4, 1. I just want to make sure you can see each step. Alright, so I've got my 1 and my 1, 0, 0. So the next thing I want to do is turn this into a 0. I can't go back. And I'm not going to say don't use this again. Don't add again. Okay, so how can I do that? Well, if I take negative 5 times this row and add it together, then I'll get a 0 there. So I am now going to take negative 5 R2 plus R3 and put that into R3. Okay. So that's, if I multiply this row by negative 5, that gives me 0, negative 5, 5, 10, and 0, 5, 4, oops, and I'm sorry, that's negative 10, 1. So that gives me 0, 0, 9, negative 9. Okay. So 1, 2, 2, 2. 0, 1, negative 1, 2, 0, 0, 9, negative 9. Okay, so I'm really close. Now, because I'm lazy and I don't want to rewrite it again, I'm just going to take R3 divided by 9 into R3. So I'm going to change this to a 1 and this to a negative 1. And I finally have my row echelon form matrix. Okay. Well, I want to remember now what this is. These are my coefficients of x, these are my coefficients of y, these are my coefficients of z, and this is what it's equal to. So this row here tells me that 1z is equal to negative 1, or just z is equal to negative 1. Then I'm going to work my way up. I know that this tells me that 1y minus 1, z is equal to 2. So that tells me y minus negative 1 is equal to 2. So y plus 1 is 2, so y equals 2. I'm sorry, 1. Then I go back to my top row, and it tells me that x plus 2y plus 2z is equal to 2. So that's going to give me x plus 2 times y plus 2 times z is equal to 2. So x plus 2 minus 2 is 2, so x is 2. So I have my ordered triple, 2, 1, negative 1. Okay, I'm going to quit there and we'll start a new video in a minute.